So here's a recent video from Sleeping Warrior. This is what a solar eclipse should look like. And his evidence seems to be this music video, which uses a CGI created solar eclipse. So I'm a little confused here because he's saying this is what a solar eclipse should look like, but we don't see this. So really, what is the point of this video? Ah, that's right. Anthony does not believe in the globe model. So what he is really saying is if the Earth was a globe, then we should see this. We don't see this, therefore the Earth is not a globe. So you're trying to make the following logical argument. If P, then Q. Therefore, if not P, then not Q. But it seems like there might be a fallacy involved here. What I need is an expert on fallacy. Ah, denying the antecedent fallacy. Thank you, Nathan. So you see, Anthony, this is the problem. You've made an assumption, but you haven't even backed it up with any evidence at all. So let's take a look into this. Here we have the first quarter moon, and we can clearly see that the shaded side is just blended right in with the blue sky. So I decided to ask you a question. Why don't we see the stars in the daytime? And you actually answered me. No, we shouldn't see stars during the daytime. They are tiny pinpricks. Well, is it that they are tiny pinpricks, or is it that the brightness of the daytime blue sky obscures them? And then you went on. Even Wikipedia tells us on the page for new moon that we should see a black disk. It's the illustration on the right of the page. So I went to Wikipedia, and sure enough, there's a graphic depicting the new moon phase. But I didn't quite see where it said we should see a black disk. In fact, I started reading the article, and here's the very first paragraph. In astronomy, the new moon is the first lunar phase when the moon and sun have the same ecliptic longitude. At this phase, the lunar disk is not visible to the unaided eye except when silhouetted during a solar eclipse. Daylight outshines the earth light that dimly illuminates the new moon. So let's be honest, you lied. This article does not say that we should see a black disk. So my question is, well, how do you think the sky turns blue? What do you think it is? Like if there's a thin layer of blue on top of the atmosphere? Because if this was the case, then yes, maybe we would see a shadow of the moon. But maybe the atmosphere is a little bit more complex. Maybe it's a phenomena that extends down through the atmosphere. Now we do know that if we shine a white light beam into a prism, it splits into different colors, and it is the blue end of the spectrum that refracts more. So what science tells us is that we see white light directly from the sun, and since blue light refracts more than other colors, the blue sky is from scattered light. And this makes sense because when I look up at the sun, I see a white sun surrounded by a blue sky. Of course, this is the actual sun size. The sun we really see is much bigger because it is so strong the glare extends way past the actual sun size. Now here is a video that I recorded for you. So you can see this is the noon sun, and this is the glare around the sun. Now I'm going to put a welder's glass in front. Now look how small the actual sun actually is. And here are screenshots from that video. Again, the actual sun size and the size of the sun that we actually see due to glare. So here's one of your comments on this video. We do see the moon, but not the new moon. There is no evidence the moon is passing in front of the sun. So why do we only see this just right before sunrise or right after sunset? We don't see it during the daytime. This is the crescent moon, and in this case the photographer was able to pick up some of the earth shine. So on the right we have the waning crescent moon, and we see this rise above the horizon early in the morning. But as soon as the sun comes up, this will disappear into the blue sky. We don't see it for the rest of the day. And the opposite is true on the left. Here we have the waxing crescent moon. Now we don't see this all day long, until the sun sets below the horizon, and then this will appear above the horizon until it finally sets below the horizon. Now we definitely know that this is the path that the moon takes during the different phases, and we know that between the waning and the waxing crescent moons there's about a 2-day period where we don't see the moon. So it makes perfect sense that the new moon is hidden by daylight, especially when we know that the moon orbit is only about 5 degrees different than the orbit of the sun. So this is a scale drawing showing the maximum moon orbit path above and below the sun. And again, these are screenshots from my video. So we know that the new moon is going to be traveling somewhere within these two lines. And look how close they are to this really bright glare of the sun. Here's a comment from Michael. We can track the sun, we can track the moon. We can track when the moon is supposed to go in front of the sun. And your reply? Don't be silly. Are you serious? It is your answer that is silly. First of all, you can look this information up. If you were looking up about the moon's orbit, I'm sure you came across what is called a lunar node. Another thing is you can go outdoors and actually make observations to confirm if this is what really happens. The moon and the sky are not locked up in a NASA vault. They're outdoors for everybody to see. In fact, there are astronomy groups that have gatherings, and I'm sure even in your area they do. They invite people to come and see. Go there. Find a 10-year-old boy or a girl that have a telescope and ask them. They can tell you. So this has been known for thousands of years. The moon orbit is about just a little bit over 5 degrees offset from the ecliptic or the sun orbit. And we know exactly where these orbit paths are because you could compare them to the stars in the background. So the moon orbit is 27 days long, so that means twice during this period the moon orbit will cross the ecliptic. And these are called the lunar nodes. The one in the front here is called the ascending node because the moon is traveling upward in this direction. The one in the back is called the descending node. This is the second paragraph from this article, a cherry you decided not to pick. A lunar eclipse can only occur when the full moon is near either lunar node, while a solar eclipse can occur only when the new moon is near either lunar node. So if you don't think it is the moon causing this, then exactly what does cause solar eclipses? Are you like other flat earthers and think it's the mysterious Rahu and Ketu? And if you think something else causes this, do you have any evidence of the moon in another part of the sky during any solar eclipse? Of course not. So let's wrap this up. Again, you have absolutely no idea of what you are talking about.